Please welcome J.C. Pastant.
Hi everyone. Wow, we are way too many, but it's okay. So let's continue to talk about dependency injection. You saw how to use it inside your code. Now I'd like to make you responsible when you use it, because as Stanley said once, great power means great responsibilities, and so there's a dependency injection and swing inject. So let me show you why. So let's take a simple example with this class, and we want to inject it with swing inject. So as Yoshi said, you create a container, you register it, and you resolve it later in your code. But let's say we forgot to register it. That happens to me all the time, because in reality you're going to create a class with a lot of code. You're going to make the resolve, and you're going to forget the register, of course. Let's try to compile this. We have no issue, because obviously the code is valid. There is no problem, so it's okay. And now let's try to run it. Okay, we may have a little bug, but nothing too fancy, obviously. And by the way, it was recorded with an iPhone XS. So let's dig a little deeper. We had a runtime crash because we got an unexpected nil optional. And of course, we had this unexpected nil optional because we didn't call register before doing the resolve. So we are unsafe. We are unsafe because we were able to resolve without registering first. And we are unsafe because I was able to launch a rocket with this code without having the compiler telling me at compile time that it would fail. And this is not really nice. We could do better. We could only be able to resolve if we registered first. And we should have a compiler telling us if we're trying to resolve something that is not registered. That would be a lot better. But how can we do this? What's the solution? Turns out there's one existing already. It's called Dagger. Does anyone know Dagger? Yeah, one or two. So Dagger is a dependency injection framework. That's pretty cool. That's a subject. And it's a compile time dependency framework. So it means that at compile time, you know which dependencies are available or not. And it does that just by generating code. So a code that a human being would have written. And how do you use it? Well, it's pretty simple, just with annotation. Well, and so with the annotation, it generates the code and you get the dependency available at compile time. But as you may have noticed, this is not Swift. This is Java, some Android code. This is not a big deal. We can all migrate on Java and Android. It's cool. Or all we can do is to create a Dagger-like tool. Yeah, it's not a big deal. We just have to create an annotation, an inject annotation, that will be providing some data to our templates that will generate our Swift code for both the register and the resolve. And here you can see that it would be one annotation that would provide both the register and the resolve code, which would make us safe. So let's do that. Let's use sorry for the inject part and stencil for the templating part. Sorry. So for the annotation, it's pretty simple. All you have to do is to put a comment with sorry inject. And what it does, it will provide information about your class once you are inside the templates. So let's dig into the templates. The first one is about the register part. So it's stencil template. So the first thing we're going to do is to loop over the inject annotation. And for each service annotated, we're going to generate the register part that we did at the very beginning. So with the type and just the init method. And what we can do also is that if the init also requires some service, we can resolve them also by calling the registered service method that we'll see after. And here the result, the generated code. So with the container.register French script provider that we forgot at the very beginning. Don't mind about the assembly part, this is Swinject, and we don't have any time to talk about it. As for the resolve template, well, the beginning is the same, we're going to loop over the inject annotation, and for each service, we're going to generate the registered service method. And all it does is to call the resolve with the force unwrapped. Yeah, and that's it, but at least we know now that this service is registered using the inject annotation. And this is the generated code. So pretty much what we did at the very beginning. And so we can now replace our unsafe example with this. And we can now call register service as French script provider and be pretty confident that it will be available at runtime. So this is when everything is okay, but what about the case where you forget to register, again, your service, when you forget to annotate it, because it happens to me all the time. So let's say that we have a new service, a new dependency, that we did not register. So let's get on our register template and make it a little more verbose. We can loop over all the service required by the init, and for all the services that are not annotated, inject, we can generate a compile time error that will make our code not compiled, obviously. And so here, for our example, instead of having the init, we can get an as compile time error saying that something else cannot be injected because we forgot the inject and not register. We forgot the inject annotation on something else class. And yeah, that's it. That's it. So to sum up, yeah, dependency injection is pretty cool. It's very powerful. But if you use it, be careful because you may have some runtime crashes if you are not careful. My advice is to use tools that will check for you if you have no missing dependency at compile time. You can find a more advanced example on GitHub, and that's it. Thank you for your attention.
Thank you. Thank you.
Jean-Mi. I need my mic. I do have it. Thank you, guys. Thank you for your talks.
Thanks. Thank you.
So,
I don't see anything. I'm blind.
We don't see no one. So there are a lot of things to discuss about, like how do you actually go from a code base that has nothing done properly on dependency injection and go to using a tool like Swinject? That's my recurrent question, but I really like to have ways to actually tie like the theoretical ideal world that we see in conference and like the real world of our dirty code base. Do you have some clues on how to go to a good dependency injection method?
Yeah, it's actually a difficult question. So usually it's easier to make the dependency injection code from scratch, but if you have to keep the existing code, I think one of the yesterday talk, it's told making a router is the good idea to start with. So you don't have to, or you shouldn't put the DI container everywhere. So you need to have the reference only from one part to the container. So usually, router or factory or builder should have the container. So making that part is, I think, the first step. And after that, you just make the dependency injection to the new part you are going to make to the existing code. So I think that is a solution, one solution.
And that's possible, like just adding swinject to the parts that you are, the new parts you're coding.
Yeah.
You can actually do that.
Yes. So the old parts still doesn't have dependency injection, but new part have the dependency injection with swinject or any sort of dependency injection.
And obviously, if you have a code that is not great, one of the first things you should do is to make your code ready for dependency injection. Most of the time, people don't do dependency injection properly. So your init methods are not well defined. So you must clean this before trying to use a tool like swinject.
Yeah, things like accessing data through singletons or things like that.
Yeah, like that, or doing A.C, .B, .C, .D, or long chain.
That's
you need to clean all of those things before trying to use a swinject.
Yes. Maybe we should write a list of things that are dirty patterns in the code where you can see, this should be replaced by some dependency injection techniques.
In a way, it was a talk by John, which covered partly the same subject about decoupling.
About decoupling, yeah. Yep. And how much time did you invest in implementing a swinject?
I think the core part is only 1 week because it's really simple. The core part can be written only 20 lines. And actually, the idea is from another framework written in C#. It is also the dependency injection framework in C# is made by a really famous person. And the idea is really cool and really simple. So I thought I could use the idea in the Swift too, because it has generics. So generics is really powerful. So 1 week is the core part.
I don't really know C# enough, but in Swift there's not much dynamism in the language. Isn't that a problem to actually implement that kind of tool? Like if you had the same dynamism as Objective-C and its runtime, wouldn't that simplify, for example, like the need of code generation or something like that?
So to make a swinject, it doesn't have problem. But as JC told, if you want to make really like Dagger style dependency injection framework, we need the custom annotation in Swift too. But still, Swift doesn't have custom annotation. So what can we do is the my style or swinject style dependency injection or the code generation style dependency injection.
Okay.
What? Sorry.
Yeah. No. There's also I want to be for a moment the devil's advocate and say, okay, that's great. You are decoupling and stuff, but isn't that adding a lot of fat to your code base? Like every time you want to add a dependency or use this technique, that it will actually make the code more fat and have more lines of code.
Well, actually, if you write your classes with dependency, and even with no framework, if you write your classes with dependency in mind, you will have to give those dependencies anyway. So, with or without framework, you will have to write all this code. I'm not sure it adds more code than without dependency. But clearly, it really helps to maintain the code.
An issue we might see in apps that use much dependency injection is to have everything as a protocol, basically. So we inject everything, you have lots and lots of protocol. Do you have an advice for that?
I'd say like everything. Don't abuse of everything. Protocols are very good, but don't use protocols everywhere. Like you don't use structs or classes everywhere. Otherwise,
so you will just register the class without the protocol.
Can you do that?
Yes.
Yes.
Yeah.
Okay, because it's true that in my career, I had some like dark moments where I had to write C# code, and I remember like the code base was full of interfaces, and that was like Inception at the end. And how do you fight that? Do you have some rules to not abuse of protocols? Tricky question.
Yeah, difficult question.
Do things cleanly and it's going to be okay?
I'd say to be first pragmatic. So sometimes just start with maybe with a class and with no protocol, and maybe after, if you have really a need for a protocol, add a protocol. It might seem stupid, but if your code is ready for injection or all those things, it shouldn't be a lot of work to refactor. And I'd say that. And the other advice I can give is don't do it like in Java. So if you're doing a protocol and a class named protocol implementation, I think your protocol is pretty useless.
Yeah, basically you don't have to use protocol everywhere. So it's usually we need protocol or abstraction to separate the two components, not just classes. But so if you have the Viper architecture, so each, the VIPER part should be defined by protocols. And also, if you take architecture that was introduced by John yesterday, so it's like lock and key. So if you make the two components, big parts are separated by something, it's just where the protocol should be used.
Yeah, so composition sometimes is a better solution than using protocol do all the things on the same class.
It's always tricky, man.
It's been the third talk in 2 years speaking about sorcery, which is for a quick panel. How many of you are actually using sorcery today in production apps? That's good. But and how many thanks to French Kit?
Oh, that's a lot.
Wow,
almost everyone.
It's
almost
everybody. So.
Or lying.
Okay, I won't ask this question anymore.
That's a risk.
do you have some drawbacks of using sorcery, in your opinion?
Well, it was the first time, so I can't tell a lot. It's pretty simple to use, pretty efficient. The only drawback I have for now is about the templates. So this is not really sorcery, but in sorcery you can do templates with Stencil or Swift. Last time I tried for Swift, it was a little hard because depending on the way you install the sorcery, it was working or not. So that's why I went on Stencil. That's pretty the only drawback I'd have about it.
One really pragmatic question is it possible to use a multiple implementation of a protocol in a container? Like, say, you have mock API clients for the unit testing and API client production.
Yeah, actually, you can register 2 or more implementation for one protocol. But if you want to do that with Swinject, you need to add some name for the registration, or you need to add some parameters to register the dependency.
And
so
how do you switch?
That adding name to resolve the one type, or if you have parameter to the registration, it's just differentiated automatically because the Swinject container is really like a dictionary. So the dictionary key is the type and also parameters added to the registration.
Oh, nice.
Yeah.
Okay, very nice. Okay.
Yes, maybe one more question. So I guess both of you used the Typhoon back at the times. It was a dependency injection for Objective-C. Is there anything you had in Typhoon that you miss in Swinject?
Missing in Swinject, your question?
Yes.
It's like maybe Objective-C style things, and also as JC told, the Swinject container has problem. It's not perfect solution because it's like dictionary. So if you forget the registration of the dependency, it may crash in the runtime. So it is one drawback.
Okay.
Okay. Thank you, gentlemen.
Thank you.
Thank you for your talk.